Oh, good. All right, good morning. Today is September 8th, 2021. This is the Kubernetes data protection working group meeting. Today we have a couple of items in our agenda. Thanks, Stephen. He offered some a long time ago to talk about AWS and the AWS controllers for Kubernetes, and this is highly related to our data protection working group. And someone, I guess, I don't know the name. Sorry about that. Is that Keith? It's going to.
But we've brought a few other people from the Kubernetes people to speak with you.
Perfect. It's going to go through this topic. And then we have a little bit updates on the data protection white paper. Then if we have time, I think Phong wants to talk about the CAP was change block tracking. And there, if we still have time, then we can discuss open issues. Now let's just get started with the AWS and the ACK. Stephen and the team, AWS team, you have the control. And Xin, do you mind make them the co-owner, whoever is presenting?
Sure.
Probably Jay. Are you going to be presenting, Jay?
Who will be presenting? I'll make Jay.
Sorry, I actually wasn't prepared to present anything. I didn't realize that I was going to be presenting. I actually thought I was just going to be answering some Q&A about ACK, but I can kind of give you guys an introduction as to what ACK is all about and our roadmap and the various controllers that we have already in preview. And
Jay, maybe you want to share some links. There are some websites.
Yeah, I'd be happy to.
And then I'll just as context for people in the group, the reason we got interested is, again, I think all of us here, we spend a lot of time thinking about what we can back up within a cluster, and that's great. But I think we all know that customers are deploying with dependencies outside the cluster, whether it's databases or file systems or object stores or whatever it is. They're linking external resources as well as internal. And so when I first heard about the ACK from AWS, some of our challenges were, how do we discover this? How do we link to it? We were sort of asking customers to kind of hand detail for us. By the way, I've got these dependencies, which is both inefficient and probably always wrong. And so we were interested in sort of this path that AWS was taking, just from a discovery and then potentially protection standpoint. So that was sort of our view on this. And I know I think Tom and I probably at one point during one of the meetings talked about different ways that we do this. And so that was really sort of the genesis of this, is what are ways that we can better understand outside dependent resources so that we can better discover, protect, recover them in conjunction with what's in the cluster. So that's the background, Jay. That's kind of what we do. That's why we said, boy, it'd be great if someone could explain to us, again, what you're doing, what the roadmap looks like, and then, like I said, this is not a shy group.
No worries at all. No worries at all. So I gave you guys a link to the actually brand new documentation site for ACK. We actually just changed our doc site from a make docs to a Hugo based system yesterday, I think, right? Amin. So anyway, welcome to our new doc site. We're still it's a still work in progress, and obviously we would love your feedback and input as to ways that we can improve the documentation and user experience of ACK. But let me go ahead and sort of rewind a little bit. So ACK is for control plane operations, not for data plane operations, and I'll get to the reason why that's important here in a second. We have a set of custom Kubernetes controllers, one for each of the AWS service APIs. So we have an S3 controller, an RDS controller, the ECR controller, etc. Sorry, someone's outside my window. So we have like I said, an S3 controller, RDS controller, ECR controller, EC2 controller, etc. And each of those specific service controllers interfaces with just one AWS Service API. The Kubernetes custom controllers that are published as Docker images in the ACK project, they are sorry. Each of the controller images uses an IAM role associated with the service account running the controller pod. And that IAM role has permissions to speak with the AWS Service API in question, S3, RDS, etc. We have the ability to support cross-account resource management as well. So a single ACK service controller can call STS assume role and pivot its client to manage the lifecycle of resources across different AWS accounts. What this means is you don't need to install an ACK S3 controller in multiple Kubernetes namespaces or multiple Kubernetes clusters just in order to manage the lifecycle of resources in multiple AWS accounts. You can use a single controller for that. And there's an annotation that you put on the Kubernetes namespace to allow for the ACK controller to understand how which AWS account to manage resources for that namespace. A lot of people ask me, what is the difference between something like ACK and something like CrossPlane or CloudFormation or Terraform? One of the big reasons, or one of the big differences between ACK's design principles and something like CrossPlane is we have these separate controller binaries, as opposed to CrossPlane, which has a single provider binary for each of the cloud providers. So there's like a provider AWS binary that speaks to IAM, speaks to S3, speaks to RDS, etc. We have a little bit of a different security stance and level of comfort, I guess, with having a single binary have IAM permissions to speak with lots and lots of different AWS services. And so we decided it was a more tenable security approach for us to publish these individual binary images, which we could scope the IAM role permissions that are running that controller just for the specific AWS service in question, so that you don't have like these God level IAM roles, right? Or super user IAM roles. That's one of the big differences between ACK and something like CrossPlane. Another big difference between ACK and its predecessor called the AWS Service Operator is we don't use CloudFormation. So many of you are probably familiar with using CloudFormation templates to structure the creation or management of a group of AWS resources as a unit, as a CloudFormation stack. We don't do that. We don't use CloudFormation. We call the direct AWS service APIs and not wrap the entire thing in a CloudFormation transaction. And the reason that we do that is because we found that because Kubernetes wants to be the desired state of the source of desired state truth, and CloudFormation also wants to be the desired state of truth. And those two things have different ideas of what that desired state of truth is. In the case of CloudFormation, it views everything in terms of the stack, right? Like the status of the stack as it moves through a series of resources. That's its definition of like the observed state of those resources. Whereas Kubernetes has a different idea of what the desired state and the observed state of a resource is, and it's more granular than the CloudFormation idea. So we decided in ACK land to sort of not go the CloudFormation route. We call these individual AWS APIs directly. So we call create bucket, and create database instance in RDS instead of calling CloudFormation stack create, essentially. Sorry, I'm a little unprepared for this. I apologize.
Hey, Jay, I had a quick question for you on that. How does that work with the role mapper, like the IAM role mapper for EKS? It seems like you're setting your own roles directly, but the way that we typically see people configure EKS is through the role mapper.
Two things. First, EKS has nothing to do with ACK. So you can install any ACK controller on any Kubernetes. You want to install it in kind, go for it. You want to install it in GKE,
Gotcha.
Go for it. Doesn't matter. There's nothing about EKS that's like specific to ACK. Funnily enough, we actually have an EKS controller in ACK, which is sort of Inception-like and very much kind of similar to cluster API provider AWS in a little ways, but we communicate with the EKS API in the ACK controller for EKS. The IAM roles that you need to execute the EKS controller for ACK, that's kind of related to the role mapper that you set up with EKS. But other than that, there's really no relation between ACK controllers in general and EKS. You can install it on any target Kubernetes cluster.
Yeah, very cool. Thanks.
So I wanted to introduce Amin. So Amin, say hi from Morocco. Amin Hilal is another engineer on the ACK team. Yes, and Amin actually developed the cross-account resource management functionality in ACK about a year ago. It was one of the earlier features that we added to ACK. I can give you a link to some of the documents that we put together for this right here. We also have an ACK community meeting on Zoom each Monday. So if any of you are interested in asking specific questions about any of the particular ACK controllers, how things work, always feel free to hop into that particular meeting.
Sorry, Jay.
Sorry.
Right. If I understand you correctly, ACK is a per service plugin or controller model which manages your AWS resources. Is that the idea?
That's exactly correct. I should back up a little bit further and state that everything in ACK is code generated. So we consume these API model definitions, something internally that we call the Coral model definitions, and we output the entire controller implementation for each of these service controllers. And this is what makes ACK sort of a little bit different than something like KubeBuilder. Like if you were just to use KubeBuilder and generate a controller that talks to S3, what KubeBuilder would do for you is, it would generate the CRD definitions as a stub, and then you'd go and make some changes to what it generated. But at the end of the day, what KubeBuilder will give you is sort of like a stub implementation of reconciler. And then you got to go and implement the meat reconciler. In ACK, we have a common runtime and a code generator that actually consumes these API models and actually spits out the full implementation of the service controller by examining the API models, the input and output shapes. We use the AWS SDK Go. It looks at the input and output shapes of the individual API calls and maps those input and output shapes to a custom resource definition, right? So for instance, in the S3 controller, we have the bucket CRD. And when we call the create bucket API in the AWS SDK Go, we're creating the create bucket input shape. And we're populating fields on that create bucket input shape with fields from the bucket CR that someone has created. And likewise, the response from create bucket, we're setting certain fields in the CR status based on the output shape. All of that code, which I like to call like SDK linkage code, it's really repetitive, super boring and tedious, and nobody likes to write it. And so we wrote a code generator that basically generates all of that really annoying, tedious code. And that code generator, ACK Generate, which I can give you a link to the source repo here.
Is there?
That code generator, oh, great, thanks. Thanks, Amin. You're already ahead of me. So that code generator is used to generate all of our ACK service controllers. And it's also used to generate the CrossPlane AWS provider. So a lot of people aren't actually aware of this, but yes, in CrossPlane, even though we have a different mission in ACK, we're a sort of lower level than CrossPlane. We don't offer that abstraction layer above the individual cloud provider. They actually use the ACK Generate code generator to take care of all that tedious, SDK linkage code that I talked about earlier, and also to generate their custom resource definitions that are specific to the AWS provider inside of CrossPlane. So it's actually been a really cool experience collaborating with the CrossPlane contributor community. They've given us a lot of feedback on how the early versions of the code generator worked or didn't work, and helped us fix bugs in the early versions of the code generator. And now their CI systems are like linked in with our code generator CI systems as well, so that we can generate when we push out a new generation or a new version of the code generator, they can regenerate their provider AWS.
Couple of questions. Do those controllers actually manage the full life cycle, and how does discovery happen? Because this, Stephen was talking about the discovery of externally managed services in the cloud or in any places, and how we back up them, right? So I want to understand how this is associated.
So if you can make most API calls to the service, if you can make that control plane API call, right? Create database instance, create DB replica, create DB cluster, those kinds of things, and the various update code paths and deletes. If you can make that call in the AWS API, generally the ACK controller is going to support that functionality. However, for doing things like backing up and restoring of like your own owned MySQL database instance or something like that, we don't support that. And also we don't support like the S3 object API or any data plane API really, right? So what we will do is give you, for instance, the endpoints to your Elasticsearch domain, right? Because that appears in the status of your Elasticsearch domain CR. But we're not going to communicate over that URI, right? Just like we're not going to send SQL commands over your database URI or anything like that.
Okay,
let's take RDS. So let's take RDS specifically though, right? Because so many people use RDS or Dynamo, right? Because I know you've got controllers for either of those. So if today, I went and created an application that said I want an RDS, whichever, Aurora or something, right? Doesn't matter, right? So I know with ACK how to specify that I want that. Are there APIs then where I could say trigger an RDS backup, or even just I can find out that this application hadn't? Yeah, exactly. Snapshot. Yeah.
So I'm currently working on that. So there is a, I know, like, well, it'll be done tomorrow. No, it won't. I'm working on it. But no, if you can call like the create DB snapshot command in the AWS API, then the ACK controller for RDS should be able to do that. Each of those create API calls, actually we represent as a separate resource. So for instance, for DB snapshot, it's a separate resource from DB instance, right?
Got it.
And so to create a snapshot, you would do kubectl apply or kubectl create -f, pass in a YAML manifest that describes the DB instance that you want to snapshot, etc.
Got it.
So yes, we're going to get there sooner rather than later. I'm working real hard to get the snapshot support into the RDS controller. RDS specifically, because there are some quirks and idiosyncrasies between the DB cluster resource and the DB instance resource, and like DB read replica and some things like that. But as I develop these resource managers within the RDS controller to handle snapshots and DB proxy and that kind of thing, and I run into these little idiosyncrasies, I'm working with the RDS service team to sort of smooth over any of those weird oddities in the API. I'm logging bugs with the RDS team to show them sort of like things that I ran into, and just generally working with them to smooth over any of the weird behavior and make sure that the RDS controller hides that weirdness from you. So it's really, you're just talking to the Kubernetes API, just calling kubectl apply, and that's it. So that's the goal.
Makes sense.
Do you support the AWS
For
backup?
DynamoDB, we already support that. Sorry, go ahead.
Oh, thanks. Do you support the AWS backup APIs?
Yes, for DynamoDB. I mean, you're talking about RDS or DynamoDB?
The general AWS backup that, there's the backup service in AWS.
We do not yet.
I don't think so.
Sorry, I'm sorry, Tom. That's actually the first time I'm hearing of it.
Yeah.
I'm a terrible AWSer. Sorry.
Let's take
That
a
makes all of
step
us in the backup space feel better. If you haven't heard of AWS backup, then I feel better about my our company.
Yeah, so don't look into it. It doesn't exist. Don't worry about it.
Let's take a step back. Jay, I'm really interested to understand, how do you model in ACK all the various actions, like each AWS API calls, into a corresponding CR? I mean, I can imagine you have thousands of APIs, right? How did you model that?
I will give you a link here. Give me 1 second, okay? I actually wrote a doc on this in true AWS fashion. 1 second. Okay, so I gave you a link to our service controller roadmap, which kind of lists the various controllers that we are currently working on and what's sort of on our radar. Tom, feel free to add AWS backup in there, and we will happily flesh out a plan to get that developed. And then is it Xiangqian?
Xiang.
Is that right?
Xiang, yeah, thanks. Yes, okay.
Okay. So there's a second link that I put in here called API Inference, and this actually goes into quite a bit of detail about how we read those API model files and determine, what is a resource in the API, and how do we map specific API calls, to create operation, update operation, delete operation. We also have this thing called the generator.yaml file. It's basically a set of instructions to the code generator about those weird oddities and idiosyncrasies and inconsistencies in each of the AWS service APIs. So we can basically say, okay, well, for this particular API, it mostly follows like a normal CRUD type of pattern, but I don't know, the update operation, the update API operation is called this instead of like update or put or modify, right? So we can kind of give it some hints as to how to find the particular API operations that correspond to update calls or deletes or creates. We also have the ability to put these generic hook points into the code. So if you think about the resource managers that go into each ACK service controller for each of the custom resources. So for instance, in the RDS controller, we've got a resource manager for DB instance. We have a resource manager for DB cluster and DB security group, et cetera. Each of those is a separate resource manager that's actually a Go struct that implements a certain interface for looking up a single resource, creating a resource, updating a resource, et cetera. And those code paths for finding a single resource, creating a resource, updating resource, et cetera, sort of follows a standardized pipeline of events. You construct the input shape, you call the API, you process the output shape that you get back from the API, and set attributes on the custom resource and return the custom resource. We have hook points within our code generator where we can override the behavior of a particular service controller. So if, for instance, there's a weird update code path, let's just say S3 buckets, right? I don't know how many of you know this, but there are 23 separate HTTP API calls to update S3 bucket attributes. It's crazy. Anyway, there's really no way that we can auto-generate that kind of a weird situation. So we add custom code hooks into the S3 controller for the update code path that calls put bucket lifecycle configuration and put bucket cores configuration and all those separate API calls. In the same way for like the RDS controller, there are some slight weirdnesses in the update code path where we know, for instance, that if you call a modify operation on a DB cluster and the engine mode is serverless, that some of the fields cannot be modified. Things like the preferred maintenance window, like things like that. You just can't set those. Otherwise, RDS will return you a big fat error, and then the RDS controller will place your custom resource into a terminal condition, which isn't good. So anyway, we have custom code points that we can, in the pipeline of processing of all the resources, we can take appropriate action. I don't know if that answers your question, John.
Yeah, it can. Because the reason why I was asking is because this working group major focus is to kind of provide a more generic solutions for backup. One of the aspects we were trying to explore but find out is too hard is how do we effectively back up services that runs outside of the Kubernetes cluster, which in this case, for example, S3 bucket or TCS bucket is exactly the same thing, right? It is exactly those services. So one of the things I was trying to understand is this, the ACK controllers generates a whole bunch of CRDs based on particular service provider using the code generator if they are. But I can imagine those CRDs will be quite different because every single provider will have their own generator YAML, right?
In fact, if you take a look at the CrossPlane XRM, the extensible resource model, and how they sort of like, obviously CrossPlane does multi-cloud stuff, right? So they work with GCP and AWS and Azure and Equinix and all sorts of things, right? That have different managed services for things like databases and object storage. So CrossPlane has this multi-layered architecture where they have an abstraction at the top that they call a database, right? And then underneath that, they have separate providers for the clouds, and those cloud providers, modules, have their own custom resource definitions that are scoped to that specific provider. So for instance, they'll have the AWS.crossplane.io database. And that is sort of specialized for an RDS database instance, right? And in that way, they sort of have this layered of, well, it's driver or provider specific. And then on top of that, they have this extensible abstraction layer that allows them to sort of, have some flexibility in sort of farming out the specialized logic to the individual cloud APIs that back those providers. Obviously, in ACK land, we don't do that, right? We're just something that they build on top of, right? So our CRDs are namespaced under services.k8s.aws. So it'll be like rds.services.k8s.aws/db instance, right? That'll be our CRD.
Yeah, totally makes sense. It's interesting because this is the pattern. It's not.
But you could certainly build on top of that, right? Like if you were interested in making a generic backup operator, you could work on top of an ACK RDS controller, right? And read and write ACK CRs and rely on the RDS controller to do its thing, and then focus on the more data plane aspects, like rely on the RDS controller to do the CRUD operations for things like DB instance, and then maybe, focus on the more data plane operations. And like if you, for instance, had to, execute an SQL, DDL query or something like that, you might do that in your operator sitting above the ACK land.
Totally, but there's an existing pattern in the Kubernetes community, which is CSI, right? It just matter.
Yes.
It just instead of taking the approach of using CRDs, it is via gRPC interface, via the CSI interface, right? So this is a slightly different approach. But thank you.
Yeah, of course.
So if I may summarize what was just said, basically, the goal with ACS is to with ACK. The goal with the ACK is to expose AWS APIs through CRDs and custom resources. And
right,
anything beyond that, anything beyond that is basically up to us. So for example, if somebody wants to back up an application that has multiple components like S3, ABS, DynamoDB, they can leverage these CRDs and controllers to do the job. But
absolutely,
application definition.
But we don't have like a mission more than just create the best generated controllers for each of the individual AWS service APIs. We don't have like a larger mission or a higher scoped mission than that.
Yeah.
Jay, I have another quick question. So in the ACK model, you mentioned the identity is an annotation on per namespace, right? So that you don't
for
need
the cross-account resource management.
Right.
Yes.
Right. If there is upper level controller which orchestrates, let's say, backup operations against a particular service, how does that account gain the permission to run that?
I mean, the service account that is running your higher level controller would need to have permissions to write custom resources and read custom resources of services.k8s.aws kinds. So just you'd use the Kubernetes RBOC model for that.
Basically, the ACK controller will use whatever the annotation on the particular namespace as the identity to talk to AWS services.
Correct. That's on the ACK side, right? Yeah, the IAM role that's associated with the service account is what the ACK controller will use when it's communicating with the AWS APIs. But your sort of higher level controller, you wouldn't need to call to the AWS APIs, right? You'd be communicating only with the Kubernetes API and writing custom resources of kind, s3.services.k8s.aws/bucket. So your service account that your controller is running in would need to have permission, read and write permissions for that kind in the Kubernetes RBOC model you wouldn't need to worry about any of the IAM permissions because that's on the ACK side.
Right, got it.
And the granularity is at the kind of top level, top level service, not the instance level. It's per account, right? So if I have multiple instances of RDS, if I have access to the control to create objects in Kubernetes through the controller, or that the controller responds to, I wouldn't be able to get access to individual RDS or revoke access to individual RDS instances.
Not well. I mean, you could by modifying the IAM policies, I guess, behind the scenes. But there's I'm trying to think whether there'd be a way to do that on the Kubernetes side in ACK. I suppose you could remove the config map item for that AWS account to prevent the controller from being able to assume that role and target that account. Like if you were worried about like you got hacked or something and a particular account is breached and you want to take remediated action about that.
I guess a follow-up question would be, let's say some changes happen outside of ACK through regular AWS APIs, or let's say we already have a deployment in AWS and we want to be able to switch over to ACK. Does ACK controller do the controllers discover the state in AWS and auto-populate these CRs or
not auto-populate? So we have this thing called adopted resource. So we thought that the auto adoption or automatically taking a resource that was pre-existing and bringing it under ACK management, we didn't like the safety aspects or lack of safety aspects of that. So instead, our resource adoption, it's explicit. Like you have to call kubectl create, you pass in a manifest that describes the resource that you are adopting. And the ACK controller sees that adopted resource kind, that CR, that is of type adopted resource, and will fetch the latest observed state and write that latest observed state into desired. So it's like an explicit thing that you have to say, I am asking the ACK controller to take this particular resource under management.
And do these controllers and CRDs, do they have like a declarative style, or this is just more like a?
Oh, absolutely, yes. Let me, do we have docs on? Yeah, this is a missing part of our docs. Let me see here. Amin, do we have any docs on adopted resource that are sort of more user-facing?
I think the SageMaker controller have some of these. Let me check. But I don't think we have some that are generic for all controllers.
Yeah, it's definitely a miss in our documentation. Sorry, Arnold.
No problem.
It's a fairly simple custom resource, and I'll just show you the definition of custom resource because that's easier. 1 sec.
Cool. While you are searching, are there any questions for Jay and Amin and Stefan?
So
I'm gonna send a link for the how SageMaker adopts resources.
Thank you, Jay.
Yeah, no worries.
All right. If there's no more questions, thank you so much, Jay, Amin, and Stefan for having this conversation over here, a discussion over here. It's totally fine. You're not prepared. That's totally okay. You know, happens all the time. And I think you did a nice job. The idea is, if not more questions, I would like to move to the next agenda. Let me present my screen. 1 second.
Thank you very much, all. I'm going to drop off now. I put a link to our community meeting. We have a Zoom community meeting on Mondays. Thank you all. I really appreciate the questions. Thanks.
It's very
Thank you.
cool. Thank you.
Thanks, Trey.
Yeah.
Thank you, folks. Bye-bye.
Take care.
Bye-bye. Cool. Let me see. Yeah, there's a whole lot of links over here. Thanks for whoever updates that. The white paper. So I took a couple of rounds, and I think Xin did as well. We were also asking each chapter owners or section owners to update these correspondingly. I think it is right now in a relatively good shape. Xin has an CR out to make ourselves the owner of our data protection working groups repo. And once that is done, I think the next step is we take this and make it an MD file and submit a PI against that. Thanks everybody who have been working hard on this white paper. Well, after I read through it, I think me personally benefited a lot from all the use cases, from all the sections we discussed, and also the component is missing and is there. If you have more updates, please do so. I think Xin and I will discuss maybe a final date so that we can have the first draft out for review. Does that make sense? Xin, do you have anything to add on?
No, I think we're good. Yeah, I think there are probably a couple of sections we still need a little bit update, but we are getting pretty close to getting this finalized.
Yeah, we'll be actively pinning. Again, thank you all who have been actively working on this. Really appreciate that. We got about 10 minutes, so Huang, please, you can take it over for now.
Oh, I just want to say that we have, I started kept just like a very initial document of it. There's a lot of things that we need to discuss. I think the main thing is that right now we define an API for our service, for the CBT service. My to all of you is, do we go ahead and try to design that service, or we just kind of state what it look like, what it should do in a general way? What do you guys think? Because from my point of view, we to create like a complete service and then let vendor attach to it, or implementing like a plugin or something like that. I think that would be more useful. Otherwise, we just state the API. It is very vague and no. I mean, it's kind of it's not really useful at all. So that I would say we implement a service and make it a way to help vendors implementing an add-on or something, or a hook on to it easily. So that's in my opinion. What do you guys think?
What do you mean by a service? Could you define it?
We let's just say like a Kubernetes service that any backup vendor can talk to when they want to get the chain block check the CBT, that's the differential snapshot of some volume, right? That is what I have in mind. But it has to be done in a way that any storage vendor can easily hook up their storage to it so that it can serve this differential snapshot. right now, the document that you guys see on the screen right now is very, very, it doesn't have a lot of material in it. It only have a defined API and nothing else substantial. So I propose that we're gonna go further and define more detail of the service, how it look like, what is it's more like an implementation of design the implementation of the whole service instead of just stating an API.
So are you talking about like having a independent service but not really part of Kubernetes? Is that what you were trying to say?
That's what do you guys think? Because
yeah, I just want to clarify, right? This is the idea still gonna take the CSI route, or I understand your service that can be built on top of the APIs, but my experience tell me that we'd better take these baby steps first. We can have a full picture like how these APIs will be used, but it will be very challenging to combine everything in one. And I'm not sure whether we want to provide a service or rather a CRD-based controllers.
We discussed about this a few months back that if we define a CRD, this CRD will stay, will you know, kind of hogging the Kubernetes API server because the response to it is very large, right? It's a long list of block of chain block, and
right.
And if that is the case, then it will, you know, hogging the resource from the API server. And then we discussed and we decided, hey, let's make it a service instead. In that case, then whoever providing the service to backup vendors, then backup vendors simply talking to that service to get the, I mean, the backup vendors simply talking to this service to get this different source snapshot.
Right, I remember that the conversation. It just whoever is using this API, what's the format of communicating as the service? It's yeah.
Yeah, but how
the problem is if we are defining this as a completely separate API, not even part of Kubernetes, then I
that is the point, right? Yeah, so that's why I want to bring it here to discuss it. Like, what do you guys think that
then we don't even need anybody else to approve. We just go ahead, whatever. It's not even part of Kubernetes. Not even, it's not part of anything.
Yeah, I mean.
But then who is going to follow that? That's a problem.
Yeah, it's part of the CSI, right? At least.
What is part of CSI? How is that part of CSI? It's not even part of Kubernetes. I'm not understanding. Have we actually defined the CSI interfaces here? Can I take a look of the, I forgot what we have. Do we have CSI APIs?
It's not in here. It's not in the CAP
that should
right
be
now.
in the, but that should be part of the CAP if we have CSI. I mean, but even that's CSI, exactly right? That's usually used by the CEOs, right? You're saying they're not used by the CEOs. It's a little strange. You have CSI not consumed by CEOs.
Yeah, I mean that's why I want to talk here. Like instead of continue digging, design, all that stuff.
Yeah, no, I don't think it makes sense. We need to get this resolved. If it's not really part of Kubernetes API, I mean, what are we discussing? I mean, the problem is that we can do something, then nobody's going to follow that, right? I mean, we want to come up with some standards.
Even if, you know, I think even if it's not part of the CSI Kubernetes APIs, I think there is some value on standardizing on a common API. Like you don't want to.
But then who is, are you saying we're having our own community? Completely, this is not part of 630 anymore? We are right now, this one is part of 630, right? So,
yeah, this API is neither a CRD or core API or whatever, right? Just a request model with the gRPC interface. It's just like another set of CSI, which is, it's gonna be really challenging to standardize that. So
I know it's challenging, but like, I guess, here's the issue, like each vendor has their own way of providing these change blocks, right?
That's okay.
In the case of NetApp, it's like the Synaptive APIs that, NetApp provides. I imagine other vendors, they have their own APIs, So obviously that part of the API is different, but I think there's still a value, like if for a backup provider, so I guess a backup provider will have different plugins or modules for each one of these vendors. And that's something the backup providers will provide. But the question is there any value on standardizing the front end? And personally, I don't know, because I feel like, basically the backup vendors would handle the backend side for different vendors. And this service is mainly meant to be used by backup vendors internally. Like users don't see any benefits of knowing the change blocks. There's really no reason for them to be aware of the change blocks, as long as the backup vendor can figure those out and replicate them.
So I had one question. So why can't we go via CSI, use CSI like this snapshot? Right. So each vendor has to provide some way, right, to give that differential snapshot list. So can't these be like a CSI sidecar for that CSI driver, which we?
That's exactly my point. So
that's
if
we're
we
discussing, I think.
Yes.
Yeah, so I think it makes sense, right? If we go via CSI, then there's a better chance we can standardize it.
Okay, so then we are deciding this has to be, so basically I think this kind of changed the discussion now. Because
no, I don't think that was initially that was the idea.
Okay, all right.
If we make it into a CSI, do we mean to have to be managed by the Kubernetes API server, like be part
No,
of?
it's not necessary. CSI
over
is
gRPC.
Yeah, it's a gRPC interface, right? What we expose in Kubernetes, I mean, we do have the concerns around the size of the CR, but we can try to see whether we can find a way out of this, or maybe, as you said, just provide a standardized service. But the interface to the storage vendors, right, should stay down. That's my opinion. I think it is still feasible to do this in the CSI level.
Yeah, so basically we are using gRPC and CSI, but we're not using CRs.
We're not saying that yet. I don't think we're saying that yet. We haven't.
That's right.
Maybe that's what we should discuss.
But
that's the reason why I think
all the previous discussions we were having,
I think there's also a possibility to have a different database, right? You can still use this model, but they can have a separate database. That's also possible.
There's an extension API service, right? This might be useful to do that, right?
So,
but anyway,
so going back to the discussion we were having like a few months ago, we were saying, like, API server in Kubernetes handles 20 queries per second, right? etcd only handles, small objects, 100 meg or smaller, So we all discuss limitations of using Kubernetes APIs for this purpose, right?
No, Adnan, there's an extension API service in Kubernetes. Instead of using the core etcd, you can use that, right? And that one is more customizable.
I see. Okay.
Right. That's again. I think we should take maybe for let's discuss this, right? Having a smaller group discussion on this. I think we should revisit a little bit on the cap and whether we should do this in CSI. I believe personally doing this in the CSI is the right way to do, right? But I also see your point. I see your concerns as well. But to Shin's point, right? If we make this a pure service and just define a service and having different implementations, this doesn't make a cap in Kubernetes.
Yeah,
right?
We can basically do whatever we want.
Okay, let me call a separate meeting with a smaller group, and then we will discuss it there.
Yeah,
okay.
Sounds good.
All right.
All right, thanks all. We are about time. One more minute. Any last minute questions? All right.
So will you send the invite to the whole group, or for the smaller meeting? For the smaller meeting, who's getting the invite?
So
Yeah.
doesn't make sense. And it looks like people are actually interested. Why do we want to have another small meeting? I mean,
Or maybe
either we can just do this in our regular meeting. We can have another one, but just invite everybody.
Okay. Okay, maybe
Sure.
because we already take most of the time for the previous topic. So maybe let's schedule the next meeting.
Mhm.
What we can do is that, right, whoever is interested, we can have a separate one. So we don't take the whole session of next data protection working group. But if you feel,
I think people are interested, right? This is the kind of like the main topic of the, I mean,
yes, what we can do is this meeting agenda doc, right? Whoever is interested, just put your name over there. Then we can send out the invitation. How does that sound? Or we can just use that next 2 weeks later, this slot. I'm fine either ways. If no more comments, then we'll let's make 2 weeks later this slot. We will discuss this change block tree. Sounds good?
Okay.
Sounds good.
Sounds
Thank
good.
you.
All right. Thank you.
Thank
Bye.
you. Bye.